Good afternoon all. I am Aditya Verma, Relation and Outreach Executive, and
I am Anushka Gupta, Designing Executive at SPRJPT Student Chapter. Honored to stand before you as the Master of Ceremonies for today's interactive webinar organized by SPRJPT Student Chapter in collaboration with SPEIT Guwahati, SPIIP, SPJNT UK, SP Dibrugarh University, SPPDU, SP Parul University, and SPUDRTU. On behalf of our entire team, I extend a warm welcome to all of you.
I express my heartfelt gratitude to Zaki sir, member of EduCave Training Academy and former SP President, for his support which has made this webinar possible. Before we proceed with the session, I'd like to briefly introduce EduCave Training Academy. EduCave was established in 2017 as a training academy for young professionals and aspiring engineers with a desire to build their career in oil, gas and power industry. As the name suggests, EduCave stands for Education Center of Academic Vision and Excellence. Starting with just a handful of students, EduCave has scaled new height of success by providing training to BE and ME Petroleum Engineering students, as well as PSc and MSc Geology students.
EduCave's mission has always been to bridge the gap between academia and industry through our campus to corporate initiatives. In today's competitive job market, finding employment has become increasingly challenging due to the rising demand for industry technical knowledge. EduCave is led by a team of field engineers with over 12 to 30 years of experience working in various segments of the oil, gas and the power industry. EduCave aims to provide job-oriented training, courses and internship, share the technical knowledge we have acquired in our respective fields, help students understand the importance of building professional networks, educate students about the different career paths they can pursue, emphasize the significance of personality development not only for clearing interviews and securing jobs, but also for sustaining a successful career in the industry. Discuss the various skills and domains required by the industry and guide students on how to equip themselves. This includes understanding the importance of being technically confident and the role of personality development in their professional journey. I request you all to stay in touch with EduCave until you secure jobs, because EduCave is here to provide a helping hand for all the students. And EduCave is proud to say that this effort has already helped more than 600 freshers secure jobs in the core field at good positions.
Without further ado, it's my privilege to introduce our esteemed resource person, Mr. Khalid Karajkar. Mr. Khalid sir is a seasoned LL-led MLWD field engineer with an impressive 13 plus years of experience.
Recording in progress.
In the drilling services in the oil and gas industry. His journey has seen him contribute significantly to the multinational companies. Mr. Khalid's wealth of expertise uniquely qualifies him to shed light on the vast array of opportunities in our field. We are truly honored to have him as our distinguished speaker for this webinar. I extend our sincere appreciation to the EduCave Training Academy for providing us with a field engineer whose presence adds invaluable insight to our discussion. Please do not hesitate to interact and ask questions. After request from many students in the student community, we have requested Khalid sir to conduct this webinar. He has had more than 400 plus students. Without further delay, I invite Mr. Khalid sir to share his wealth of knowledge and experience with us. Over to you, sir.
Thank you everyone for this introduction. So, on behalf of EduCave, I welcome you today for this webinar that has been organized for the students. That is drilling services, a field aspect. So, let us start with this and let's see how it goes. Talking about me, thanks a lot for the introduction that was given by Aditya. Yes, I am Khalid. I'm a BE Petroleum Engineer from MIT, graduated in 2009. And since then, I started working in oil and gas industry. I have around 13 to 14 years of experience both in onshore and offshore and also deep water operations. So my experience lies mainly in, or I should say only in drilling services. So in mud logging or MWD, I started working as MWD, then LWD, then geoscience. So most of my experience is in MWD and directional drilling field along with geoscience. So for today's topic, as we all know, it's about drilling services. Drilling services in oil and gas industry encompass a variety of specialized operations and technologies designed to efficiently and safely drill wells for hydrocarbon extraction. So let us talk about few drilling services that are used in the industry. The key services includes mud logging. I hope everyone knows about mud logging. It's a process of analyzing the drilling mud and the cuttings brought to the surface during drilling operations. Mud loggers especially, they monitor and evaluate the properties of this drilling fluid and the formation cuttings to provide real-time data about the geological formation that is being penetrated or that is being drilled. And the key task of the mud loggers are usually to collect and examine the cuttings, identify the rock types and potential hydrocarbon presence. They also monitor gas levels, detecting the hydrocarbon gases released from the formation, and along with that they also record the drilling parameters like your depth tracking, then ROP, then weight on bait, pump pressure, standpipe pressure, etc. So mud logging guys, they help us to take timely decisions to optimize drilling performance and ensure that the well is drilled optimally. So I hope we will not be touching a lot on mud logging. It's basically we use surface sensors to monitor the well completely during the drilling operation, prior to drilling operation, and post drilling operation also. So mud loggers are usually involved throughout the life of the well. So these are also called surface logging engineers or surface logging system engineers, because most of the data that they monitor are with the help of surface sensors. The second most important service that is included in drilling services is MWD. I hope everyone knows about MWD. So to talk about drilling services, I know that it's a vast topic. We have around 1.5 hours. We'll try to have a macroscopic view on all the topics or all the services that are involved in drilling operations. So talking about MWD guys, MWD refers to a process of taking measurements downhole during drilling operation. As the name itself suggests, it's measurement while drilling. These measurements include directional data, tool phase orientation, and various drilling parameters. Like for drilling optimization, you require the data of downhole pressure, then your temperatures and vibrations. So these are the measurements that an MWD tool takes. We'll try to see that in the coming slides, but just to give you an overview of drilling services, let us talk about it, like what are the key objectives or primary objectives of MWD. The first most important is it gives us real-time data that helps us to maintain a wellbore in the right trajectory, and also to keep the drilling environment optimized. That is the basic job of an MWD service or MWD engineer. Along with that, when we talk about the formation, we have LWD. So this is a technology that we use to acquire formation evaluation data while the wellbore is being drilled. Unlike the wireline operations, we try to get the data during drilling operation. So formation evaluation data, when we get in real time, it really helps us to take real time decisions and reduce the non-productive time also by eliminating the need to halt drilling, or if you want to conduct a wireline logging, we stop drilling, we pull out a pole, and then we go with the wireline tools. So as compared to that, this saves a non-productive time also. Last but not the least is directional drilling. So usually on a macroscopic view, these are the four services that are used in drilling operations. So most of these services are now, there are a lot of job opportunities also, so that was the reason this topic was thought to come up with. So let's hope that we have a productive session. To start with, MWD services, guys. So as we just talked, it's a service in which we get real-time instantaneous data from our non-mag MWD tool, which helps us for wellbore positioning. When I say wellbore positioning, it's all about directional drilling and drilling optimization. So with the help of real-time instantaneous data from MWD tool, we can achieve wellbore positioning and drilling optimization. So most of the drilling operations nowadays, it does have MWD services. Second is also a process of acquiring measurements from this kind of MWD tool, usually which is a non-mag tool. So why do we have non-mag? It's because there are certain sensors, or one sensor I would say in the MWD tool, that can get affected by the steel body. That sensor is called magnetometer. I hope you know that. That sensor is very important to understand the whole direction, that is the azimuth. So let's see how we have some slides on that. We'll try to see in how much deep we can talk about it in 1.5 hours. So basically, MWD services is that there is an MWD tool which has sensors and which senses the data and that transmits the data to the surface in real time. So this data is usually transmitted in the form of pressure pulses. So usually I'm telling there is different way of transmission also. Nowadays we have drill pipe telemetry or sonic or even EM telemetries. So when we use the word telemetry, it is how we are transmitting the data. So in short, in layman language, MWD service is a service in which we get data during drilling, which is mostly associated with the directional drilling part of the well and the drilling optimization of the well. So that is basically MWD services. What about the tools that we use? MWD tool, as every tool needs a power supply, MWD tool also needs a power supply. There are two kinds of power supply that we can use in MWD tool. First is battery operated. So might be there is a tool we call in mostly probe-based tool that we use. These are battery operated tools. You just connect the battery, the tool is powered up. Or else the mostly used is turbine alternator configurator tool, wherein there is a turbine and with the help of turbine we can generate power, because I hope everyone knows that during a drilling operation there is a continuous flow of drilling mud. So if the drilling mud flows to a certain GPM or it can cause a turbine to rotate to certain GPM or certain RPM, the tool can be powered up. So once the tool is powered up, MWD tool has different sensors that are used for measurements. So which sensors does an MWD tool have? Basically it has 4 sensors, I would say, mostly. I won't include the formation evaluation sensor that are there in some of the tools in MWD, but with respect to MWD there are 4 sensors. The first one is accelerometers, the second one is magnetometer, third one is your pressure sensor and your temperature sensor. So this accelerometer helps us to understand what is the inclination of the hole. The magnetometer sensor in the MWD, non-mag MWD tool, helps us to understand what is the direction, where the well is going towards. So accelerometer and magnetometer plays a very important role in the directional drilling. Apart from that, we have pressure sensor, annular or borehole pressure sensor. Mostly annular pressure sensor helps us to understand what is the equivalent circulating density, that is your ECD, that we keep monitoring in real time, because to keep a drilling environment optimized we need to keep monitoring this data. And then we have temperature sensor also to understand what is the bottom hole temperature, because with respect to that we can make some measurements, or it is also important for the rheology of the mud. For mud program, we need to understand what temperature will be there at the bottom. So those are few sensors that we have in MWD tool that helps us to sense the data. Once the data, or once the sensor senses the data downhole, we need to send that data to the surface, and that method of transmission is called telemetry. Mostly in industry we use mud pulse telemetry. You might have studied in your college, that is MPT, but there are different telemetry methods also which are defined on in which way they are channeling. So there is mud pulse telemetry, there is EM telemetry, wired drill pipe telemetry, sonic telemetries. So as of now, I would just try to focus on MPT because that is where that is what industry is using mostly in MWD operations. So this is an overview. Are you guys able to hear? Because I'm just trying to talk to the laptop. I just need to know that we are able to hear and everything is going good. So this is about the tool of MWD, guys. So it's basically, there is an MWD tool that we program on the surface, and we run that tool in the hole to get the directional drilling data and the data that can help us to keep an optimized drilling environment in real time. So when we get this data in real time, that helps us a lot to take decisions and to achieve our wellbore trajectory, to keep the wellbore optimized while drilling. The third is, yes, as we were talking about, the most important real-time data, guys. In our industry, time plays a very important role, and if we get data real-time, it is really helpful to make decisions. And with respect to MWD data, as I told, to keep the wellbore positioned in the planned trajectory. If we keep getting the data in real time, it makes our life very easy to achieve the target. So MWD services have that ability to give real-time data, that like if we are drilling right now at 2,000, 3,000 meters, we get that data, what is going on down there within fraction of second. So that is the ability of MWD tool. So what we get from them is your wellbore positioning data, that is your inclination and azimuth. We get this data real time. Second is your temperature data, that is your bottom hole circulating temperature. Then third is your pressure data, that is helpful for your ECD calculation. And last but not the least is your vibrational data. When your drill string during drilling operations, your drill string can undergo a lot of vibrations. Usually, I think you might have studied in your college, there are 3 kinds of vibration mostly. There are a lot of, in combination there are many, but they are segregated in 3 parts, that is your torsional, then your lateral, and your axial vibrations. So when your drill string goes into these kind of vibrations, there is a high possibility that can cause first of all, the wear and tear of the tool. Secondly, an MWD tool is a combination of your sensors, your electronics, and if this tool undergoes a lot of vibration during a drilling operation, there is high probability that the tool might fail. If the tool fails, as I told you, this data helps us a lot to achieve the direction of the hole. If we do not get data in real time, we cannot drill ahead, because usually in industry we do not do blind drilling. So if the tool fails, you need to completely change the tool. You need to pull out the tool to the surface, change the tool, and then go back. It might involve a lot of time, and when we say a lot of time, a lot of money is involved in it. So it is the duty of an MWD engineer or a directional driller to understand what kind of vibrations the tool are facing, And when we understand this, we can take real-time action to mitigate those vibrations and to keep the drilling environment optimized. So vibration also plays a very important role, and millions of dollars are spent on the tool, on the servicing of the tools because of the vibrations that are faced. So you need to understand how to mitigate those vibrations also. So what about the data flow? So once, okay, I don't know. How we fix failures by vibrations is, okay, so we'll take I request the host to take the questions and we can answer them at the last, if how much time we get, So to just answer this particular questions with vibrations, when we understand what kind of vibrations we are getting, say for example, if you're getting an axial vibration is something when your drill string moves up and down. So if you understand that you are getting an axial vibration, for mitigation you can increase the weight on bit. Why is your drill string moving up and down? Because there is not much weight on bit to keep the bit on the surface. So one way of mitigating axial vibration is to increase the weight on bit. Imagine, for example, you are getting a lateral vibration. Lateral vibration means sideways vibration. So when you get these kind of vibration, the way of mitigation, one way would be to reduce the RPM. So these kind of control over your drilling parameters like your flow, the GPM, the RPM, the weight on bit can help us to achieve a good drilling environment. Talking about the data flow, when we start drilling, when we take the tool downhole, the tool senses the data. Now the data needs to flow to the surface in real time so that we can utilize that data and convert that information into critical insight to take real-time decisions. So how do the data flow? So usually when the tool gets data over here and it encodes it in the form of binary format, it gives it to the pulsar. So there is one tool, that is your MWD tool, which has sensors inside it. This tool, when senses the data, there is another tool in the BHA, your bottom hole assembly, which is called pulsar. This pulsar is the transmitter of MWD2. So this pulsar creates the pressure pulses, and through the mud channel, the pulses flow towards the standpipe pressure sensor. So who is the transmitter for MWD data? Usually it's the pulsar. And who is the receiver of MWD data on the surface is your standpipe pressure sensor. So once the standpipe pressure sensor gets the data, then with the help of a cable from the pressure sensor to the unit, then towards your local programming unit, we add some filtrations and we decode the data, and that is how we get the data from downhole to uphole. To give you a brief idea about it, this is how it is. Like these are the pulses that we get, and these are the data that these pulses travel, and we try to decode it, all this data. So in MWD service, there is a tool that senses the data. Through the pulsar, you send that data to the surface. So on the surface, there is a standpipe pressure sensor which acts as a receiver. From standpipe pressure sensor, we get it through the cable. Like the pressure pulses travel to the standpipe pressure sensor, it gets converted to electrical pulses, and then we get it onto the surface in our unit in this format. And that is how we get data, guys. So this is the graphical representation of that. Like the tool senses the data, sends the data in binary format to the pulsar. This pulsar creates pulses. So how you create pulses? Okay. So pulsar is basically a tool that has a poppet wall and what should I say? Okay, it obstructs the flow of the fluid. It obstructs the flow of the fluid. When it obstructs the flow of the fluid because of your control wall assembly, then what happens is when the flow is obstructed, there is an increase in pressure, and that increase in pressure is called a pulse. And this change in pressure is detected by your standpipe pressure sensor, and this is nothing but your pressure pulses. So the pulsar, by obstructing the flow, like, let me check if I can show you. Okay, so there is a tool. This is, for example, this is the pulsar. There is a restrictor over here inside this, and there is something called a solenoid activated valve. So this keeps moving up and down. This solenoid is spring activated. This keeps moving up and down. So once this valve body goes and sits in this restrictor, so what happens is the flow of mud that is coming from the top, from the drill string, is obstructed over here. So the pressure was like this before when it was down. When this valve body goes and sits over here, what happens? Because of the obstruction, the pressure over here rises. So there is an increase in pressure. This increase in pressure will keep on increasing till the time this valve body is sitting over here. Once this valve body again comes down, and this is again something like this, it's free from the valve body, the flow again starts flowing. So this increase in pressure again comes back to the normal. Again, when the valve body goes up, sits over here, again there will be increase in pressure. So this keeps on happening. This is nothing but your pressure pulses. So what is a pulse? Pulse is any change in pressure detected by your standpipe pressure sensor. It terms itself as a pulse. This pulse carries the data. So now, if this pulse is of this height, for example, if I make this sit over here, the valve body, for a longer period of time, what will happen? The increase in pressure will be more. So the pulse height is more. So this is what we call as data rate. So I won't get into much deep, but I'll just tell you. So what is data rate in terms of pulsar? The rate at which you transfer the data is called data rate. Now, for example, data rate can be of, say, 1 second, 2 seconds, 3 seconds. Now, 1 second means that this valve body is sitting here for 1 second. So in this 1 second, might be there is this much increase in pressure. So once it comes down, again the flow starts, it comes down to normal. If I allow this to set for 2 seconds, what will happen? 1 second, this 2 seconds, it will be the pulse height. This is the pulse amplitude. The pulse height would be more. So you can identify the pulses more easily. However, in this 2 seconds, you are keeping this idle for 2 seconds. And so, for example, this is 3 seconds. So if I want to identify the pulses or decode the pulses, it is very easy for me to use the data rate 3, allow this valve body to sit here for 3 seconds. I will get a good pulse height and I can decode the data. But we need to understand, when this valve body is sitting over here for 3 seconds, it is not transmitting data. So either you can get a good pulse height or else faster data. So for example, if I'm drilling and if I want only directional data, so I do not want to pump up a lot of data by my pulsar, so I might choose this data rate, or for example, I might choose this data rate because I do not want to pump more data. I just want inclination and azimuth that should come up. But if I want inclination azimuth. Along with that LWD data, for example, gamma, resistivity, porosity, density, delta rho, photoelectric absorption, your sonic data, your magnetic resonance data, all this data, if I want in faster thing, then I might choose this data. So the data rate is this 1 second right now. So lesser the time, faster is the data that I get, and less is the pulse amplitude. So this is something. So I would just request you to write these things down: data rate, pulse amplitude, and check what it is. So this is just an overview of MWD. No? So once we get this data, for example, if these pulses we get, these pulses travel through the mud channel. Now you also need to understand the pulses, when they start traveling through the mud channel, the pulse amplitude can decrease if the mud density is more. With the depth, the pulse amplitude might decrease again. If there is compressibility in the mud, you will not be able to get data. So you need to understand all these parameters also, the hydraulic concentration also. So as an MWD engineer, as a petroleum engineer, your job is to understand what is tool that you get, yes, how it works, most importantly, what all parameters affect my tool. Once you understand that, then you can do some real-time correction and get the data. So as of now, okay, if the mud is incompressible, you get this data, and this data is received on the surface by my standpipe sensor. Once I get this data at my standpipe sensor, these pressure pulses are converted to electrical pulses. Through a data processing unit or local processing unit, I add some filtration software and I get this data onto the laptop. So whatever was transmitted, I decode it here onto the surface. This is the job of an MWD engineer, guys. You need to program the tool to send the data. You need to understand what all things we need to program so that we get right data with the pulsar, and to understand the mud channel or the geology of the mud, there shouldn't be any compressibility, and that is how we get data. So this is an overview of the data flow for an MWD engineer. Any questions for as of now?
Yes, sir, there are few questions.
Okay, let us check.
Sir, I will tell this question to you one by one, and you can answer it. The first question is that if we provide real-time data and both of them provide data while drilling, between LWD and MWD, what is the difference and which one is better and mostly used to obtain better accurate data?
Okay, so the difference between MWD and LWD, as we were just talking, when I talked about MWD tool gives you data which are related to directional drilling and your drilling optimization. It doesn't talk anything related to the formation, whether the formation is shaly formation or non-shaly or sandstone, limestone, hydrocarbon. It is not telling you any information about your formation evaluation. So the major difference between MWD services and LWD services is that MWD services talks about the directional data and the drilling optimization. LWD, whenever you hear a word called logging, it's more related to the formation. So that's the most basic difference for MWD and LWD. And what was the second question?
So second question was which one of them obtain more accurate data or precise data?
Okay. When we talk about MWD or LWD, both these services obtain accurate data. Because if it doesn't obtain an accurate data, it can screw up the well completely. For example, I hope everyone knows what is inclination, right?
Yes, sir.
Inclination, or for the example for direction. If MWD tool gives me this direction, that the well is going in this direction, and if it is not accurate in real time, in reality, for example, if it is going in this direction, there might be a well over here which can collide. So when we say MWD or LWD or any services in the industry, when they are utilized, the technology is in such a way that they all obtain accurate data, because the quality of data plays a very important role in our industry, in every industry in that case. So MWD tool obtains accurate data about directional drilling. LWD tool obtains accurate data about formation evaluation. I hope that answers your question.
So the next question is, the question asks, can you describe what are the data or parameters sensors collect?
Okay, can you describe, so what are the parameters or data? Okay, so for example, if we talk about a sensor called accelerometer. What is accelerometer? Accelerometer is a sensor that is used in the MWD tool that responds to Earth's gravitational field. With the help of that accelerometer, we can understand what is the inclination of the hole. Everyone has accelerometer in the mobile, right? So when you look like this and you turn your mobile like this, your screen changes. Why is it changing? Because there are accelerometers over there. So what kind of data does it record? It records GX, gravitational field in X direction, that gravitational field in Y direction, gravitational field in Z direction, GX, GY, GZ. So for example, this is the tool, this is the Z direction, this is the upside, the high side is X direction, and orthogonal is Y direction. So GX, GY, GZ, this is one set of the two, data that the MWD understands. So GX, GY, GZ. Similarly, for your magnetometer, this is a sensor that responds to Earth's magnetic field. It calculates again the magnetic field in X direction, MX, MY, MZ. Your pressure sensor, it calculates your annular pressure. Your temperature, it calculates the temperature data. So from annular pressure sensor, you understand what is the ECD. From temperature sensor, you understand what is the temperature. This temperature again plays a very important role, because the sensors that are calculating all this data, they are rated to calculate the data at certain limit. For example, a sensor can work up to say 120 degrees Celsius. So you need to know that what is the temperature down there. If it is moving more than 100 degrees Celsius, that means there is a high probability now the sensor can fail. So what you do as a petroleum engineer, I guess you have studied in your college that there is one function of a drilling mud, which is cooling the BHA. So what you do is you stop drilling, you use that function. Now you just ask the driller to circulate the mud to cool the BHA and try to get the temperature down. So when we know that the temperature is rising, we try to get it down by using that function of the mud. So it's all about what you study in the college and how is it implementing in the field. If you know that, you're there in the game. Okay, any other question? I hope that answers the question.
Yes,
So the
sir, there is
next
another
question-
question.
Okay,
The
there's
next
one.
question is from Asad Ali sir. He has just completed an MSc in geology, and he's seeking an advice on how a recent graduate can stand out and land a job in oil and gas industry despite the common requirement of prior work experience in job postings on LinkedIn.
Okay, so this is an overview question, but yeah, I'll just take it and then we'll move to the technical part of the presentation. So, Asad, the thing is that for every graduate, as everyone wants job in the industry, believe me, there are a lot of job opportunities in the industry. So what is required from a fresher is that you need to know the basic knowledge, what is required in the industry. For example, if as a fresher, if I ask you, you are a geology fresher, if I ask you, in a gas zone, what would be the delta rho? If I ask you, which resistivity curve tells us talks more close to the true formation data? If I ask you, what is the photoelectric absorption branch of electron for sandstone? So if you have this information, if you have this knowledge, it becomes very easy for you to clear that interview and get it. So what is required from a fresher is that you need to know the basic knowledge, what is required in the industry. For example, if as a fresher, if I ask you, you are a geology fresher, if I ask you, in a gas zone, what would be the delta rho? If I ask you, which resistivity curve tells us talks more close to the true formation data? If I ask you, what is the photoelectric absorption barns per electron for sandstone? So if you have this information, if you have this knowledge, it becomes very easy for you to clear that interview and get a job and excel in that particular field.
So what industry requires is good technical knowledge. And the second part of your question, more common requirements for prior work experience, that's not true. Most of the job opportunities, we try to get the freshers. When we get some projects, we go and check if we can get freshers who can run the show, who can do the job. So we go and start interviewing the freshers. When we interview the freshers and we see that they don't even have the basic knowledge, if I ask you, how do you do depth tracking? And if I get an answer like, so the drill pipe is 10 meters, we'll keep calculating how many drill pipe goes in. That is not how we work, right? There are sensors like drawworks and hook load. When calibrated, we get exact depth tracking. So if you have that information, if you have that knowledge, we know, okay, this guy can work with us. But if you do not have that, then you are the freshers who forces us, because we want to run the show. So we go back to the HR and we tell them, okay, man, we need to have experienced person, because these freshers are not that much knowledgeable as of now. So we go back to the experienced people. As a fresher, I would suggest you get technically competent, and that is how you can get jobs in the industry. I hope that answers the question, Asad. Okay, so how do you determine correctness of MWD data in case of tool failure? So there is definitely, you need to know the quality of the data, like for example, when I talked about the sensor accelerometer, we know that root of gx square plus gy square plus gz square is equal to 1 Gauss, that is the acceleration, 9.88 meter per second square, right? So if I get a data, like, you need to first understand what is the SOP, the standard operating procedure to calculate inclination. What is inclination? Inclination is with respect to vertical plane, where is your well going? How much inclined your well is? This is inclination. So now you need to know, if I want inclination, I cannot move the string up and down, or I cannot move the string, because the accelerometer sensor is trying to calculate gx, gy, gz. And we all know that the total gravitational force is, say, 1 Gauss. If I get an answer which is, say, 1.5 Gauss, it's not right, because it's not possible at all that the gravitational field is this much. So how I got this answer? Because might be, first, there is sensor failure. Second, might be when I was taking the measurement for survey, the driller might have moved the string. So the sensor might have calculated gx of some part, gy, gz of some other part. So he doesn't know that for a survey, for the inclination, for the directional direction of the hole, for the azimuth, we cannot move the string up and down. We cannot rotate the string. So as a petroleum engineer, this is what you need to know. It is not it's not only that you should know the definition of inclination, the definition of azimuth. No, you need to know how you get that data, how you get inclination, how you get azimuth. So there are certain quality check. For example, with G total data, there is plus or minus 0.003 Gauss. That is what we check, if it's plus or minus above that data. Okay, I'm really sorry for this. I don't know. I was talking and I didn't realize that there's no net or something. I hope now I'm able to hear me.
Yes, sir. You are clearly audible and the screen is visible, sir.
Okay. So let's go with the slides and then we'll take questions, So with wellbore positioning, as I talked, we get two data, that is azimuth and inclination. With respect to sensors, for azimuth, we require both accelerometers and magnetometers. For inclination, we require accelerometers only. Inclination is an angle measured in degrees, the wellbore to vertical plane. So whenever we say that that means the inclination is 0 degree. When we say that we are increasing the inclination drilling or 90 degrees well, that means the well is this way. So the inclination is 90 degrees. That is inclination. What is azimuth? Azimuth is the whole direction with respect to north. Is the hole going in this direction, in this direction, in this direction, direction. That is called azimuth. So again, BHA placement plays a very important role, guys. For inclination, your stabilizer placement will play a very important role. For azimuth, your non-max spacing will play a very important role, because as I told, magnetometer is a sensor that is there in the tool that calculates this. However, if your steel body or drill pipes are near to this particular tool, which is non-magnetic, there is a high possibility that it can magnetize the tool, and the data that the magnetometer is getting is not the Earth's magnetic field, but also of this. So because of this, it will not pass the quality check. As someone asked me, this is something that we check. So it might not pass the quality check, and that can that will let us know whether we have to accept the data or we do not have to accept the data. So this is Velbo positioning. Okay, can someone tell me how much time do we have so that I can plan accordingly? What was told to you? Is it 1 hour, 2 hours lecture? How much?
Sir, it was from 1 hour to 1 hour 30 minutes.
Okay, so we'll go ahead with few slides. After 15-20 minutes, whatever we cover, and then we can take question answers.
Sure, sir.
Okay, so with respect to drilling optimization, guys, for MWD, these are the 3 sensors we talked about. And with the help of pressure sensor, we understand the whole condition. With the help of ECD, with the help of temperature, we understand, for example, the sensor limitation with respect to temperature. For example, if while drilling the temperature is this and suddenly there is an increase in temperature, there is a vague interpretation we can say. There's only one fluid down there which is at higher temperature, that is a formation fluid. If there is an influx, there is a probability that increase in temperature might happen. So it's all about interpretation of real-time data. And the third is your vibration. This is your bit bounce, that is axial, lateral, and torsional. So with this data, okay, this is the effect of your vibration, guys. The bit damage, the wear and tear of the tools and all. So with these kind of real-time data, we can interpret what needs to be done. For example, here, as I was seeing, there is an increase in ECD. And if you do not understand this language, what is happening over here, and if you keep continuing drilling, what is ECD? That equivalent circulating density. For example, if your drill cuttings are generated and they are not being able to lift up and they are accumulating in the annulus, there is a probability that this can cause an increase in ECD, pack off situation. Because of this, there is a probability of downhole mechanical stuck up. So these kind of indication from your sensors like annular pressure and all, if you can read it, what you can do here itself, what you can do is you can stop drilling and you can use another function of drilling mud, which is to get the cuttings out of hole. So all the cuttings that are accumulated, you can stop drilling, do not generate more cuttings, and clean the hole. We call it hole cleaning. So once you clean the hole, what will happen? The ECD will start coming back to the normal. So you're not generating more of the cuttings over there, or you're not loading the annulus. So these kind of interpretations can help to keep the drilling environment optimized. Okay, talking about directional drilling, I won't get into much detail. As everyone knows, directional drilling is a service in which we try to achieve a target. So there are 2 directional drilling tools usually industry uses. One is your mud motor. Second is your RSS, rotary steerable system, or rotary steerable stabilizers. So our job is not to only know what is directional drilling, like you know about inclination, you know about azimuth, but how to do it in reality. So with mud motor, this is something we call tool face. What is tool face? Tool face is an angle which describes where the mud motor bend is pointing towards. If you know this direction, you can control the bit walk, or you can control the bit direction. So if you want to increase the inclination, for example, you need to know that what the tool phase is. If I keep the tool phase as 0, the inclination will increase. If I keep the tool phase as 180, the inclination will decrease. If I keep the tool phase as 90 degrees, then the inclination will not change, but the azimuth will change towards right direction. So you should know about this also in directional drilling. This is what I was talking about. Because we get only one chance to put the hole in right direction, guys. In our industry, this plays a very important role. You cannot mess up with this data. And all this data, the tool phase data and all, we get it from MWD tool itself. So no directional drilling can happen without MWD services, because MWD tool is the tool that helps us to understand what is this tool phase orientation. Okay, so this is about directional drilling. I hope there are questions. We can answer them at the end. But I just wanted to complete this slides. But let's hope that during question answers, we can take it. Okay, as someone talked about LWD, we already talked about it. LWD is a services in which we get real-time data of formation, nothing related to directional drilling, nothing related to drilling optimization. Any tool, any service that gives you data about the formation, that is logging while drilling. Okay, so this data will allow us to understand where we are drilling. Do we really have hydrocarbon present out there? If yes, how much, and everything. So for LWD, why do industry needs the LWD services? Because they want to know, can they make money? When they say money, they want to know, is hydrocarbon present there? If yes, where it is, how much it is, and can they produce it economically? To get the answers to these questions while drilling, we use LWD technology. With this data, they try to take decisions of optimized wellbore positioning, of reservoir characterization, so all this data are used for high value decisions. So it is very, very, very important that this data that we are providing in terms of logs is of high accuracy, comprehensive, and quality data only. As a petroleum engineer, as a geology student, understand one thing, guys. A tool is developed to give you raw data. The tool gives you raw data. To convert that raw data into quality data, it is your job, because you need to understand what are the effects, downhole effects, the borehole effects a tool can undergo. Only once you understand that, then you can apply corrective action. For example, what I'm trying to say here is, if this is the formation and your tool is in contact with this, so now whatever the formation data, the tool directly gets it. However, when we are drilling, this is the hole, the tool is this. In between there is mud, right? The sensor is here. For example, just a basic layman example. For example, the gamma ray of this formation is 80 API. You need to understand, once the gamma ray travels through the mud, there will be attenuation. There will be attenuation. When I say attenuation, some of the gamma rays are eaten up. Then when these gamma rays travel through the steel body, there will be attenuation. So till the time this gamma ray comes and is being detected at the sensor, might be you're getting 50 API gamma only. Is this the right data? Is this the quality data? No, this is the raw data. You need to understand that this mud of what density can eat up how much gamma ray. This color attenuation, what is the OD and ID of this? Calculate that, and then to convert this 50 to 80 is your technical knowledge. So we in industry we say a log is as good as the technical knowledge of an engineer. This is your job. You need to understand what is happening down there. If potassium is present in the mud, KCl mud, this potassium will emit extra gammas. Instead of 50, there will be 89. Instead of 80, there will be 100, because potassium also emits gamma. So there is potassium, uranium, thorium that emits gamma rays, right? So you need to know when to apply a positive correction. Positive means from 50 to 80, how to get it. When to apply a negative correction from 100 to 80, how to get it. You need to get right data, because with the help of this data, high value decisions are made. So you need to know that. Only if you are good with understanding your downhole effects, then you can give a good qualitative log. There are various effects that happens downhole. Like for resistivity, there are a lot of effects, right? You have your anisotropy, your calibration data, your dielectric effect, your polarization horns, your beddings. All these data will start affecting your data. So you need to know all these things. See this. This is your current value. This is an example. This porosity. Where do we get porosity data from? Have you studied about neutron porosity tool? Yes, I hope yes. So you need to understand that the porosity that we get from neutron porosity tool in the log, we cannot use that data directly to calculate the saturation. I'm just giving you an example, okay? Just to make your mind creative enough to understand why, as a petroleum engineer, you're sitting over there to control the data quality. You need to understand this data that the porosity tool gives you is the total porosity data. But for saturation, Archie's equation, SW is equal to A upon porosity raised to M into RW by RT. That porosity, what you're using to calculate saturation, it is the effective porosity. So for that, you need to understand what is the volume of shale, what is the porosity of the shale. That porosity minus the total porosity is the effective porosity. If you use the total porosity, your complete saturation goes wrong. So if your interpretation is wrong, there's a lot of money involved in it. So as a petroleum engineer, I would suggest not only to understand, like, for example, this is what you guys understand. Okay, if I want to know whether it is when we are drilling a rock, whether it's a reservoir rock or non-reservoir, whether it's a shaly or non-shaly, there is gamma ray tool. Once it's reservoir rock, whether this reservoir has water bearing or whether this is oil bearing or hydrocarbon bearing, we have resistivity log. Once we understand it's hydrocarbon, whether it's gas bearing or oil bearing, we have neutron porosity and density log. This is what you have studied, but this doesn't end over here. You need to understand what resistivity log, what are the different resistivity logs, which are the different curves in resistivity logs, what is attenuation, what is phase difference, all these things you need to understand. So I think the time is limited, but I would suggest, Zaki, if students are interested, try to get a logging while drilling webinar also, because there's a lot involved in it. For example, if this is the log, right? This is a gamma ray. Gamma ray log is basically used to understand whether it's a shaly formation or non-shaly formation. So I'll just give you a brief idea. What is gamma ray? Gamma rays are emitted. These are naturally occurring radioactive stuff that are emitted by isotopes like potassium, uranium, and thorium. Potassium, uranium, and thorium are mostly in the clay particles. So whenever there is high gamma ray, that means there is a probability that potassium, uranium, or thorium are present. So this is shaly. So high gamma rays are usually termed as shaly formation. Low gamma rays, non-shaly. My zone of interest is this in the first track in quick look interpretation. Once I understand this, okay, it's non-shaly, I check the resistivity. Resistivity is a log that tells us about whether it's a water-bearing zone or hydrocarbon-bearing zone. As of now, I'm just trying to give you a layman explanation. So when we know if there is water in a room and if I apply current, the current passes through the water because water is highly conductive. Highly conductive means less resistive. Hydrocarbon, on the other hand, are highly resistive. So see this becomes my zone of interest. High resistivity means it's an indication that it might be a hydrocarbon bearing zone. Then we go and check your neutron porosity density. If your neutron porosity density, there is a crossover, it is usually a hydrocarbon bearing zone. I mean to say a gaseous zone, a gas zone. If they are overlapping, there might be a possibility of oil zone. So this is how we do a quick look interpretation for any log. If it's shaly or non-shaly, we understand it from the gamma ray log. If it is hydrocarbon bearing zone or water bearing zone, we understand it from resistivity. If it's oil bearing or gas bearing, we understand from this. But this is just a quick look interpretation. There are many things involved in it. What things? Why there is a separation in resistivity. See this, these all are resistivities. What do you mean by attenuation? What do you mean by phase? What do you mean by 2 megahertz? What do you mean by 400 kilohertz? All these things you should understand as a petroleum engineer. Why there is difference between the logs? Which of the curve do you take the true resistivity curve? Because for calculating Archie's equation, we need that data. In gamma also, you need to know if the hole size increases, I need to apply positive correction or negative correction. If the density of mud increases, the gamma reduces, then the data that is calculated by the sensor will be less. I have to apply positive correction. If there is potassium chloride, potassium in the mud, the data, the gamma calculated by the sensor is more. I have to apply negative correction. If there is chlorides in the mud, the neutron porosity log will be affected because the neutron cross-section capture area of chlorides are more. So all these data you need to know, guys. This is the job of an MWD, LWD, or a geoscientist or geophysics, So this is something I would say, just to wrap up the session. There is a lot you need to understand. It's not only about the theoretical knowledge, but how you implement that knowledge in the field. So if you know that, then it becomes very logical to understand about various logs or various services that you use in the industry. See, these kind of curves are there. Out of these curves, there is one curve which is true resistivity. If you do not take that curve value and take some other curve, the whole saturation goes wrong. The whole interpretation goes wrong. So you need to know that also. You also need to start from basic. These are depth versus data. How do you get a log? If someone asks you that also, a tool, say for example, this is a gamma ray tool. A gamma ray tool have a sodium iodide scintillator detector. So this tool will only understand what is the data of this formation. It doesn't know what is the depth of this. So you should know how you get a log. Log is always what is the response log, the formation response at what depth. How do you get it? You get it with the help of drawwork sensors and hook load sensors. So for example, on surface, there is drawwork sensor and hook load sensor, which tells you that at what time, what is the depth. For example, currently it is 3 hours, 15 minutes. The depth is say 2136.80. So on the system, I can see this. So from surface, I understand at what time, what is the depth. The tool has a clock inside. If I synchronize the tool with the laptop timing, so I first connect the tool on the surface. Both clocks should read the same value. If not, then you will never get a log. So I first program the tool. Now I synchronize the time. So now what the tool is calculating is at 3 hours, 15 minutes, the gamma sensed 82 API. So now this 82 API is of this depth. So like this, you get depth tracking. This is how you get logs. If you do not know that there is something called synchronization of the time with the laptop or with the system that you're using on the surface, you can never get a log. So you need to know all these, guys, and that is what we try to tell you. Yes, 1.5 hours is very less, that I know, but we tried our best. We always keep trying our best to educate you. as a fresher, try to relate what you're studying in college to the field. That would make more sense. I think now I'll take the questions. So which is RTS? Yeah, with this, I would say the new world is waiting for you guys. The only thing is that you need good technical knowledge to unlock the opportunities. And on that note, thank you for being present. I can take questions for half an hour also, guys. So if you want, I know in these we can talk a lot. I can talk about gamma, resistivity, porosity, density a lot. But now I hope if you ask questions, we can talk on it, because this was mostly an overview presentation on the drilling services. So I just want, it was an effort from my side to make you understand. It's not only about understanding the definition of this. It's about, okay, if gamma ray is there, you need to understand what corrections are required. What do you mean by attenuation? What do you mean by 2 megahertz? Why is there separation in curves? So all these things you need to understand. So I hope I can take good questions now. So feel free to ask your questions. I'm ready to take the questions now. Any questions as of now?
Yes, sir, there are questions.
Okay, let me check. How do I check it?
Sir, we will convey the question to you. You just
Okay.
answer them.
Just a second. Thank you, sir, for your enlightening presentation. Your insights has provided us with deeper understanding of the vast opportunities in the field of drilling services. Before we conclude, I would like to remind all the participants to kindly fill out the feedback form provided in the chat box. Input
Sir,
is
now it's
valuable to
time.
us. Additionally, I encourage everyone to follow the LinkedIn page of EduCave and share your reviews on Google. Now it's time for the Q&A session. I invite participants to ask any questions they may have. We can take
So
up
the
the
first question goes like this. How PWD tools measure mud density, sir?
Okay, so I'll just take questions. Wait, I have this. Okay, I don't have that question, might be because I logged off and logged in. Okay, PWD is nothing but your pressure while drilling. It doesn't calculate, so it's usually, it calculates your annular pressure losses. The annular pressure sensor, it calculates the annular pressure losses, and with the help of annular pressure losses, you calculate your ECD. So PWD, the pressure while drilling tool, is usually to calculate your ECDs, because ECDs plays a very important role. For example, if you are drilling at a very faster rate, you're generating a lot of cuttings, and those cuttings, if they are not being lifted up from the annulus, there is a possibility that the ECD will increase. So the change in ECD, the increase in ECD can let me know, or I can interpret in such a way that if ECD is increasing, that means the hole is not cleaned. The cuttings are being accumulated in the annulus. So the increase in ECD, I can interpret it in this way, and then I can just stop drilling and keep circulating out the mud. So that is one part of ECD. Second is, for example, if there is an influx. If, for example, there is an influx while drilling, and suddenly there is a drop in ECD. So, okay. Are you able to see the screen?
Yes, sir, it is visible.
Okay, so for example, currently the ECD was going normal while drilling like this. Suddenly there is a change in ECD, increasing trend. That means over here, there is a possibility that the hole is not cleaned. So I can stop drilling and I can circulate out the cuttings. The ECD starts dropping down and becomes normal, and then I can drill ahead. If you do not stop drilling over here and the ECD keeps on increasing, you suddenly starts getting spikes. This is called pack-off situation. There is a high probability of stuck up. Might be, it can also lead, if it increases to such a level that it fractures the formation, then there will be losses. If losses are there, there is a high probability of differential stuck up also. So this can create problems, downhole problems. So this is one example of increase in ECD. So we have to keep a track on increase in ECD. That doesn't mean that reduction in ECD is nothing. If suddenly there is drop in ECD, why would ECD drop? Might be you need to have you can even interpret it in this way. There is an influx of gas, for example, into the hole, a cave. So what happens is gas has an ability to expand. It wants to reach at the surface as soon as possible. In this, what it does is whatever fluid is there, it tries to unload it. So the fluid pressure exerted on the annular pressure sensor is less, so the ECD calculated is less. So there are various ways of interpretation of ECDs also. So I hope that answers your question.
So the next question is, if mud logging also gives formation data from mud cutting, what is the difference between mud logging and LWD? Are both the two things necessary?
Okay, so MWD and mud logging and LWD are different in a way. Okay, once you're drilling, for example, at 3,000 meters you're drilling, the cuttings at 3,000 meter, when it comes at the shale shaker, it will take time. How will the cuttings come at the shale shaker? Okay, I think I have to keep. Okay, let's see it in this way. For mud logging, what does mud logging guys do? If I'm drilling at this particular depth, so the cuttings that are generated of this particular, for example, 2,900 meters. Now these cuttings, it will take time to come to the surface. Through the flow line, it will come at the shale shaker, and at the shale shaker, we get these cuttings and we examine this. So there is a time lag, we call it lag time. Till the time these cuttings comes over here, might be instead of 2,900 meters, you are at 2,906 meters because there is a lag time. So this is called lag time. So first of all, we are not getting the data real time. After some amount of time you're getting. Secondly, you are identifying this and then you say that, okay, this is 70% clay stone, 30% sandstone, and 10% in that limestone and all those stuff. But in LWD, it gives you real-time data. It gives you exactly like exact data as compared to mud logging. Mud logging, it's a third eye. It gives you an overall data. We get a mud log on that. So formation evaluation can be done more accurately in LWD. It doesn't mean that mud loggers do not give right data. It's a macroscopic data. For example, with LWD operation, LWD tool like formation pressure testing, you can understand what is the formation pressure. With LWD tool like NMR, nuclear magnetic resonance, you can understand what is the, whether it's a movable fluid, it's an immovable fluid. You can talk about the permeability and all. Mud loggers cannot tell you that. What is the movable fluid, immovable fluid, permeability and all. So nowadays, there are a lot of high-tech tools that have been included in LWD family and Violin family. Mud loggers are mostly of surface sensors and geological interpretation of the samples. So this is the difference. More accurate data or more descriptive data you can get from LWD tool, the imaging tools of LWDs and all. I hope that answers your question.
So the next question is, how does gyro tool works and what data we can get from the gyro?
Okay, gyro is a different services. I won't get into much into it, but I'll just give you an answer to let you know what exactly I mean. Gyro is when I told you for like when I'm drilling, okay, in casing, for example, in casing, I cannot give you azimuth because in casing is a steel body, it affects my magnetometer reading. So I cannot give you azimuth with the help of MWD tool in casing. However, with gyro tool, it's not seeking needle. So with that, the complete principle is different. It can give you azimuth with gyro tool. So gyro tool is different from MWD in terms it's a north seeking tool, north seeking needle tool, and this is working on magnetometers. So again, the use of that is to provide the direction of the well. So when we are not able to use MWD, usually we use gyro also, or else gyro with MWD also we run gyro to get more micro data of inclinations and azimuth. I hope that answers your question.
So the next question is there any material you can suggest for LWD and MWD?
Material, I think you can get in touch with Educave. We made some material for MWD and LWD. There are many books also. I would suggest, right, I'll take this opportunity to suggest you is just do not read the basic of tool, the working principle of tool. As an engineer, it's good to know the working principle of tool. Okay, for example, and I shouldn't get. Okay, for example, you all know that a resistivity tool. Let's talk about resistivity. Resistivity tool is what? Resistivity tool it gives you a log which can differentiate between hydrocarbon bearing zone and water bearing zone. This is what you might have studied in your college or books, But do not stop there. You need to check on what principle it works. It works on an electromagnetic wave propagation theory. So when this resistivity tool, this is the formation, it has transmitters. It has, say, 5 transmitters, 6 transmitters, I think so. So 2 receivers. So let's think it has 6 transmitters. So this 6 transmitters transmits electromagnetic waves inside the formation. This electromagnetic waves goes inside the formation. For example, this is the electromagnetic wave. Now, depending on the conductivity of the formation, this wave the shape of the wave will change. For example, the energy is lost and it comes at this way. This change in the signal amplitude of the wave is called attenuation. And how much degree shift has happened is called phase difference. These two plays a very important role. You should know that. And for example, a tool emits, say, 400 kilohertz frequency, and 400 or some companies emit 500 kilohertz frequency, and another is 2 megahertz frequency. Why do a tool emit 2 frequencies? You should know that also. So this is your job to understand what is happening here. Because, okay, I won't get there are different theories on it, right? Dipolar rotation or cation exchange, ionic movement and all. So what happens is this tool, I'll give you a small example, 500 kilohertz. The ability of this frequency wave to go deeper inside the formation, to read the formation more deep with respect to 2 megahertz. The 2 megahertz depth of investigation we call. The depth of investigation of low frequency is more than that of high frequency. So if someone asks you to give you a resistivity curve which has the ability to read more deeper inside the formation, you give 500 kilohertz curve. When someone asks you to give a resistivity curve which can read more near to the formation or more nicely vertical thin beds, for example, if this is the formation, homogeneous formation, so this is the tool I want, this is the curve I want, because more deep inside the formation I'll get more true data. What if there are thin beds like this? This curve is not being able to resolve it, but 2 megahertz curve, which reads more near to the formation, can understand the thin beds also. So 500 kilohertz curve is used to understand the depth of an investigation. 2 megahertz is used to understand the vertical thin beds. So these kind of detailed knowledge you should know, and you should start reading these kind of stuff. I would say, Zaki, if you have something from Educave, kindly share it in the group that can help these guys. I hope that answers your question.
Sure, sir.
Okay, let me check the two questions now. I'll take the ones which I feel is logical. How does gyro tool work? Okay. Please tell me about the future of RTOC as a petroleum engineer. It's a good future, I would say. I don't know who this is. Real-time operation center is a good future now because most of the jobs are being governed from a real-time operation center. So when we say real-time operation, you need to understand what are the skills that are required. Again, the skill required is the same. Surface sensors. You need to understand drawworks, hook load, pump stroke, standpipe pressure sensor, weight on bit sensor, torque sensors. You need to understand how to interpret the data because this data you get in real-time operation center and you take decisions from there. So if you know these kind of interpretation, the future is really good. In India, we have already started in some projects. So if you're good in interpretation part, if you're good in your softwares, your systems and your downhole sensors interpretation, you have a good future in there also. I hope that answers the question. Process to get free certificate, I think you can check with them. Guys, certificates, okay. Believe me, certificates is not something what industry wants. So you can definitely use this certificate to make a CV out of it. You can tell the industry what you have done because certificate is something that will sell you even before you sell yourself. But the importance is what is a CV? The CV is a question paper that you're making for yourself for an interview. So now if you get this certificate of drilling services and you write in there that I attended a webinar on drilling services, which enhanced my knowledge about MWD, LWD, directional drilling. So now you need to know if a question comes on directional drilling, if a question comes on LWD, if a question comes on MWD, are you able to clear it? I would say a smart student would be that student who will only include this certificate in the CV if he thinks he can answer the questions. So that is what I would suggest, on this. Zaki and team, kindly check how you're giving the certificates. Okay, as a fresher, what all safety courses we have to do or any software language? I would say courses, safety courses, it's my personal opinion. So it's not like I might be wrong also. I would always prefer you to first understand the operations, then get into the safety courses. First do what is must to do. Safety courses are good to do. You can, if you want a career in HSC, definitely you can steer yourself in those courses. But as a petroleum engineer, if I'm talking, I would say first, let's try to understand, let's try to learn the operations, the conventional methodology, and then go towards the safeties. Secondly, software also. I've been seeing a lot of software courses coming up nowadays. On LinkedIn, I see a lot of courses coming up on softwares. With all due respect, again, this is my personal thinking. You cannot do a software course online without having hands-on experience on a laptop at the same time with a version of software that you're using in a span of 10 to 12 hours. You cannot do that. That is what I feel. However, I would say if you want to do a software course, it's good you do it, but you need to first understand the basics of it. For example, if you're doing some geoscience software course, if you yourself do not know what is the importance of volume of shell, if you yourself do not know what is the importance of T2 cutoff lines, what is a software? I believe a software is that when you give a right input, you get a desired output. But if you do not know the inputs, the importance of inputs, directly jumping to software is not the good idea. So I would say definitely go and learn softwares, but again, try to learn the basics first, the operational needs first, understand the principles, the things that are affecting my tools, how the data is getting affected, how I can convert the raw data into quality data. If you understand that first, then go towards the software that will make your life much logical. Okay, there are many questions. That's good to see. Okay. What is this? Same thing I'm getting.
So we have one more question. Why downlinking is necessary in MWD?
Okay, why downlinking is necessary in MWD? So what is downlinking, guys? You need to understand. So, okay, the data that MWD tool is sending onto the surface, this is called uplinking. The data, we are linking the data upwards. So the MWD tool is talking to me when I'm sitting on the surface. MWD tool is talking to me. MWD tool is trying to link the data upwards. This is called uplinking. For example, if I want to give a command to my MWD tool, if I want to link a command downwards, that is called downlinking. So when I use, say, for example, an RSS tool, a directional drilling tool, I send a downlink to the tool, my MWD tool, to change the direction. If I want to move the well in right direction, I command the tool from the up from the surface. So I'm trying to send a data. I'm trying to talk to the tool downwards. So it's a bidirectional communication. When the tool talks to you, when the tool sends you data, that is called uplinking. When I am trying to send data to the tool, that is called downlinking. Why is it necessary? It might be necessary for many things to achieve a good directional job, because RSS tool is governed by downlinking. For example, in a tool, there are 2 gamma ray sensors and one sensor fails, sensor 1 fails. So what I can do is I can downlink the tool to start the sensor 2. I can do that. I have to program the tool first on the surface with all the downlink settings. Then I can command the tool, okay, the sensor 1 has failed. Tool now start transmitting second sensor data. So the tool now will start sending us gamma ray 2 sensor data. It's that way. So for example, the data rate, if I want to change the data rate of the tool, for example, I kept data rate as 1 second. In 1 second, I am not able to get good data. I'm not able to decode. Now I want to make the data rate as 3 seconds, for example. So what I can do is I can downlink the tool. I can tell the tool, okay, now instead of making the pulsar idle for 1 second, you restrict the flow for 3 seconds. Thereby you are increasing the pulse amplitude and I can decode the data. So these are the things why we use downlinking. I hope that answers your question.
So this question, the next one is something personal. He's a mechanical engineer now working in an HR department for 2 years. He has undergone MWD online internship from Educave twice. He started to understand what's happening in the industry. So is there any possibility that he can pursue the career in the industry? And should he go for masters in order to do so? He is currently 28. Please advise.
Okay. Okay. Is there a possibility I can pursue career in this industry? Yes, definitely you can pursue career in this industry. Freshers, I think most of the freshers from Educave, I have seen many freshers got placed in MWD in various companies. So you are a mechanical engineer with 2 years of experience, but mostly in HR department. But you have that knowledge of MWD. I hope you have that knowledge of MWD if you have done the course. So you just need to wait for the right opportunity. I know that a lot of opportunities are not there, but as of now, in September or October, there will be opportunities coming up. So as a petroleum engineer also, you need to look for the industry, what industry is doing right now, who is getting tenders, which tender is opening when, all these updates you need to know. So if you see in September or October, there will be a tender opening, and whoever gets that contract, there will be an opportunity that they will start hiring. So you can wait for that. Should I go for masters in order to do so? In order to just get a job, I wouldn't say, but yeah, education is always good. But just to get, if you think that just by doing masters you can get an upper hold, I don't feel so, frankly speaking. Again, this is my personal opinion. So for enhancing your knowledge, definitely if you want to go for masters, you can go. But if you are thinking just by doing masters, the probability of getting jobs would increase, I don't think so personally, to a certain extent. So I would say, if you have done the course, keep yourself updated, and let's wait for an opportunity after the session. Give me a message if you have done the course. If I was your trainer, I don't know who this is, 1+LE2111. So give me a message, send me your CV, let me check when you did the course and what opportunities we can come up with. Are there MWD tools that can test the formation fluid in situ while drilling in real time? There are not, Charles, there are not MWD tools, but what exactly you mean formation fluid in situ? If it is formation pressure, there is formation pressure testing. If you want to do hydrocarbon typing, then you can have nuclear magnetic resonance technology that can tell you about light hydrocarbons and heavy hydrocarbons and all. So I hope that is what you wanted to ask. A fluid characterization can be done with LWD tools in real time. Yes, the movability, the immovability, depending upon the T2 cutoff lines, we can identify what is the partial porosity of the formation, what part of it can be movable, what part of it cannot be movable, what is the light hydrocarbons, where is the heavy oil. So that we can do with NMR technology nowadays. Please throw more explanation on difference between resistivity, 2 megahertz, 100 kilohertz. Okay, so these are different resistivity frequencies that a resistivity tool in LWD operations uses, So, okay. It's basically, when we talk about a lower frequency, it has an ability to travel much deep inside the formation. So that lower frequency resistivity curve helps me to understand more depth of investigation of the formation. However, if I want to understand the true formation, I also need to understand the thin beds of the formation. I need to present that again. Okay, for this. Okay, here it is. Say, for example, this is a formation.
So sorry for interruption.
Mhm.
Can you please open your camera as well so that people can see you?
I don't know. There's some problem in the camera, but let's go with the answer. I tried to
No
open
worries.
the camera, but it's not visible. Okay, so if this is the formation, and if there are some thin beds like this, so if I have this is again a layman language of explanation. Okay, there are a lot of physics involved in it. We can talk on it. It can take around 2-3 days just to understand the electromagnetic wave propagation theory. So just I'm giving a brief overview of it. If, for example, I emit 400 kilohertz frequency, the ability of 400 kilohertz is that it will go deeper inside the formation and come back at the receiver. So this ability, this much is called depth of investigation. But when he's doing this curve is not able to understand these thin beds. These thin beds, it's not taking into consideration the effect of these thin beds. At the same time, 2 megahertz, he will travel less deep, but he will take into consideration the thin beds also. So 400 kilohertz frequency wave, or 500 kilohertz frequency wave, or 250 kilohertz frequency wave, or low frequency wave has an ability to reach much deep inside the formation. The depth of investigation is much higher. However, 2 megahertz have lower depth of investigation, but better vertical resolution. Better vertical resolution means it can resolve the thin beds nicely. It can resolve the thin beds nicely. So if you see this, where is that? Okay, if you see this log, this means this curve, 2 megahertz, is a curve that can tell me about thin beds also. Thin beds also. This curve will tell me about depth of investigation, about something here, depth of investigation. What is phase and attenuation? Phase and attenuation, as I just told you, this is phase and attenuation. So now this is attenuation and this is phase difference. Again, these two have a property. This is an electronic property. Okay, to give you a brief, I call it always I effect. It's not, I call it I effect. I effect means, I call this I as in P. P means phase. It is an electrical property of phase that it investigates radially. It investigates radially. Attenuation has a property to investigate toroidal. So who will have more depth of investigation? Attenuation will have more depth of investigation as compared to phase. As compared to phase. So now, okay, I'll take this. I'll show. Okay, there are two families. Resistivity, I'm giving you layman explanation. Depth of investigation curve and vertical resolution curve. Depth of investigation means someone who is reading more deep inside the formation. So with respect to 2 megahertz and 500 kilohertz, who will read more deep inside the formation? 500 will read more deep inside the formation. And 2 megahertz will read good thin beds. 2 megahertz. With respect to attenuation and phase, who will read more deep inside the formation? Attenuation will read more deep inside the formation. Phase will read radially, that is, it can help us to understand thin beds also. So this is phase. Then, as I told you, this is a tool. These are transmitters. This is receiver. This is long space transmitter. This is short space. So long space has an ability to go deep inside the formation as compared to short space. So long space. And short space will read good vertical thin beds. Now, if I tell you a curve, let us see this curve. A resistivity curve of 500 kilohertz, attenuation, long space is the curve that will read more deep inside the formation as compared to a resistivity curve of 2 megahertz, phase, short space. So if a geologist asks you to give a resistivity curve which has an ability to read more deep inside the formation, you will give him this curve. If geologists ask you to give a resistivity curve which can even have an ability to read thin beds also, you will give him this curve, 2 megahertz phase difference. True resistivity, usually in industry we give 2 megahertz phase long space. It's a combination. So there are various effects a resistivity tool undergoes because of which the values are different. The curve starts separating. Those effects I call usually in field, I remember it as A, B, C, D, E, F, and SHIT, SHIT. These are the effects a resistivity tool can undergo. When I say ABCDF SHIT, I mean, for example, A stands for anisotropy, B for Borel effect, C for calibration, D for dielectric effect, E for eccentricity, F for formation type, S for sensor limitation, H for horizontal bedding, I for invasion, T for thickness. Because of these effects, the separation happens. So there's a lot involved in it, but yeah, this is a basic idea. I hope that answers your question, brother. So 2 megahertz, 400 kilohertz, okay. Where is this question? These certificates is done as soon as possible. Any other questions you might have seen?
No, sir. I think we have covered all the questions, and
So
there are
any
the same.
webinar on course about WITS-ML, we can do that. WITS-ML for RTOC, we can do that. I'll check with the trainer. We do have. Are tech course must required to study for job in petroleum industry? The courses are not must required, guys. You need to understand nowadays a lot of platforms are coming up with courses along with Educave. But personally, being a face of Educave, I always tell one thing: keep courses as last options. What is must required is that you need to get knowledge from somewhere or other. Get it from professors, get it from college, get it from online, get it from anywhere, but get the knowledge. If you do not have that knowledge, you will find it very difficult to clear those technical interviews. That was the reason Educave came up with this thought process of training the students only from field engineers. We are proud to say that we are a platform that have field engineers training the students. So what we do is whatever skills are required in those 12 hours of shift, we train the students exactly that, the job oriented courses. So courses are not must. It's good if you want, you can do it, but if you don't want to do it, get some alternative and get knowledge for that. I'm a fresher. What are the interview questions that we will get for the HR or the management? Okay, so these kind of questions, it's when you talk about HR, HR is someone who tries to understand what your personality is. So there are basic questions from HRs, right? They first try to ask you about yourself, then what are your 5 strengths, your 1 weakness, where do you see yourself in 5 years and all. So these are very scripted questions, but there's a lot they judge about your personality. I'll just give you a small example. If I ask you, what is your 1 weakness? The answer usually what I get is during the interview that, sir, if guys are there, they just try to portray that I'm very short-tempered, I'm very lazy and all this stuff, HR, when you answer these kinds of questions to an HR that I'm very short-tempered, what HR listens that if he is a short-tempered guy, if in a team, if I put him, he will be short-tempered and there is a high probability that there will be issues in the team. He will not take you. He judges you from that. What is your strong 5 strengths? 5 strengths come something like I'm a hard worker, smart worker, this and that. But these have to come up with an answer, a scripted answer, something like, I would appreciate if I get an answer like, so 5 strength is, I always remember it as TRAII. T stands for I'm a team member, I'm a responsible person, I'm an accountable person, integrity and innovation. These are my 5 strengths. So when you're trying to portray yourself in $1 million industry, you need to be good with your answers. You just cannot come up with few answers like I'm lazy, I'm not punctual and all those stuff. So I hope that answers your question. So for HR, it's all about the personality. The questions are repetitive, but they try to understand what personality you have. I hope that answers your question. All the things are done when. Any questions, guys? I think, yeah, that is it.
Yes,
So this
sir, I
is the
think we
last
have
shout
covered all
out.
the questions.
Okay. So I think, guys, that is it from my side. If you have any questions, this is the last shout out for the questions, or else we can end it for the day. Any questions? Okay.
I think no, sir, there is no question.
Okay.
Yes.
So thanks a lot, guys, for being there, for listening. And thanks a lot to Parul University Students Chapter also for being the technical assistants, and other student chapters also. Feel free to get in touch with Educave if you need any kind of free webinars and all. And I wish you all the best for your future. Hope to be in touch, guys. Thanks.
Thank you so much, sir.
As we draw near to the end of our webinar, I want to express my gratitude to all the attendees for their active participation. Your engagement has made this event truly enriching. In closing, I want to extend my heartfelt thanks once again to Mr. Khalid sir, our resource person, the faculty member, students of RJIPT, and all participants from various universities. Your presence has made this webinar a resounding success. A special thanks to SP Parallel University for the technical support providing with the link and making this insightful webinar possible. Once again, I would like to thank all the universities on behalf of SP RJIPT Student Chapter for joining this webinar. and making it a great success. Until we meet again, thank you and have a wonderful day ahead.
Thank you, guys, and just request you to give the feedbacks. That always helps educate. Thanks a lot, and have a good time.
Thank
Find
you.
this with